All right, so today we're going to do 10.6, which is finding segment lengths in circles. We are, we're going to transition from arcs and angles to lengths. So we're not looking at the measure of an arc or an angle right now. We're looking at segment lengths. So segments of a chord, when two chords intersect in a circle, we have the chords are divided into two segments. So the chord AB is divided into AE and EB. And then we have ED and CE. The secant segment is a segment that contains a chord of a circle and has exactly one endpoint outside the circle. So a secant line intersects the circle twice, but secant segment is this part, and then the external part of the segment is this part, which we'll write down in a second here. The tangent segment over here, that touches the circle at one point and it intersects that external segment. Okay, so the external segment is the part that's outside the circle, so just this part of the line. Okay, so we're going to have three theorems that you have to learn to complete these. So they're going to all be different pictures. So this one is when we have two chords intersecting inside. So those parts, so this segment, if I take EA and multiply it times EB, that's going to be equal to DE times EC. So you take the part of the line times part of the line, and then it's equal to the other one. So if you were adding them, then the lengths would be equal. But in this, the chord lengths are not equal. It's the parts multiplied together which are equal. So for example 1, we have to find what X is in order to find M, L, and JK. So we're going to set this up. So we have LM. So LN is X plus 3. So that's one part, times the other part, NM, which is X plus 1. Then we have the other side. It's equal to these two parts multiplied together. So X times X plus 5. For the left side of the equation, we're going to have to do something similar to what we did in 10.1, where we used FOIL, or the distributive property. So you're going to take this X and you're going to multiply it times the first X. So you get X times X squared, or X times X, which is X squared. Then you're going to take that X and you're going to multiply it times the 1, so plus X. Then you're going to take the 3 and multiply it times the X, and 3 times 1. Okay, so you multiply that first term times the other two, and then the second term times the other two. The same thing is going to happen on the right side, except for we only have one term to multiply by the other two. So we're going to take X times X, which is X squared, and X times 5, which is 5X. So I'm going to simplify this. And then we're going to subtract the X squared to get it on the same side. But what happens is they cancel. So I have 4X plus 3 equals 5X. Then I'm going to subtract 4X. So X is 3. Okay, the next picture is two secant segments. So you have two secants that are intersecting the circle at 2 points, but they're segments, so they don't go on forever. This equation, this theorem is going to be EA, which is the external part, the outside part, times the whole thing, so EB. and then EC times ED. So outside times the whole. So what I like to remind myself is I'm taking the outside times the whole thing. Okay, so the outside piece times the whole thing, EB. Okay, so I'm going to write that down here. Okay, so for this segment, the outside part is 6 times the whole thing. The whole thing is 4 plus 6, which is 10. And then for the other one, the outside piece is 5 times the whole thing, which is x plus 5. We add them. So this gives me 60, and then we're going to distribute. So 5x plus 25. And subtract the 25, so you get 35 equals 5x. So x is 7. Oh, and I forgot to go back and find ML and JK on those ones. Sorry about that. So ML, on this last one, we found x equals 3, so we're going to plug that in. So MN is 3 plus 1, so that's 4, and 3 plus 3, which is 6. So ML is 10. And then JK, we have 3 plus 5, which is 8, and 3. So JK is 11. So they're not equal, but if you take 8 times 3, that's equal to 6 times 4. They're both equal to 24. Sorry to go back to that one. So this one, it just said to find the value of x. So we found the value of x. Okay, and then our last theorem is very similar to that second one. Now we have a secant segment and a tangent segment. So the tangent segment, there's the outside part is the same thing as the whole thing. So you just take it times itself. So it's squared. So the tangent part is squared, and then the other part is still outside times the whole. So you would have EC times ED. Okay, so for this one, the tangent part is x. We're going to square it outside times the whole. Then we have the outside is 3 times the whole thing, which is 27. So x squared is equal to 81. And I'm going to square root that. So x is 9. Okay. So those are the 3 theorems. Now I want you to practice finding that on your own. So I'm going to show you 3 different examples. You need to match up what picture it looks like and see if you can try it. So here's the first one. Pause the video and then start it again so you can hear the solution. Okay, so this one is the one where I take the part times the part. So I have 9 and 5, and then 3 and x. So 45 equals 3x, so x is 15. Okay, pause the video and then try it, and then I will show you the answer. Okay, this one is the third one, so we take the tangent and we're squaring it, and then we do the outside times the whole. So the tangent part is x, and we're going to square it, and then the outside part is 4 times the whole thing. 12 plus 4 is 16. So x squared equals 64, and I'm going to square root that. So x is 8. And then our last one, before you write this down, I want you to change one of the numbers here. We're going to change this to be an x and this part to be 10. That just makes the solving a little bit easier. So this is, pause the video. Okay. After you've worked it, this is the one where you take the outside times the whole. So the outside part here is 10, and then the whole thing is this x plus 10. And then over here we have the outside part is 8, and then the whole thing is 8 plus 8, which is 16. So now I'm going to take 10 times x, and 10 times 10, which is 100, and 8 times 16, which is 128. Subtract 100. So 10x is 28. So x is 2.8. Okay, let me know if you have any questions. I know that the multiplying two binomials is something that you struggled with in 10.1. So go back and watch that video of that 10.1 explained, where I explained that example, if that is still something you struggle with, or just rewind this video and go back to that example and try again. And I'm always available, so if you need help, let me know.